Mental health signifies the well-being of behaviors. These behavioral problems affect mind and brain, altering emotions and cognition. It has typically obscure etiologies, ambiguous diagnostic criteria, and blurred lines between distinct illnesses. About 450 million people endure mental illness daily. Society is heavily burdened by mental disorders. It is critical that it accounts for 12% of the worldwide burden of all diseases. Lancet Commission reports that mental disorders are on the rise and will cost the global economy $16 trillion by 2030. DSM-5 lists 300 mental disorders, with schizophrenia and depression being among the most serious. Depression is one of the main global burdens of disability worldwide. WHO warns that by 2030, depression will overtake diseases as a primary reason for disability. And it is assumed to deteriorate after the COVID-19 pandemic that caused a 25% increase in the global prevalence of anxiety and depression. Also, schizophrenia is a severe mental disorder that affects people's ability to work or study normally. About 20 million people suffer from this chronic mental illness. Besides, it is a financially ruinous illness. In 2002, the overall cost of treatment, medicine, and unemployment in the U.S. was projected to be $62.7 billion. The crucial problem of mental care is the impaired diagnosis techniques that heavily rely on participants' awareness. But now, technology is providing automated and objective assessments for mental status based on the body and mind association philosophy. The story of body and mind started too long ago when philosophers rejected Plato's belief that mind and body are completely independent. By 1923, William Samuel Jones takes a step forward, linking lifestyle to both physical and mental health, and declaring that changes in behavior can induce changes in health and mind. Since then, several studies have considered human physical activity to identify mental status. And lately, alterations in motor activity measured by different sensors were used to assess the participants' mental status. This study is exploring the potential of applying artificial intelligence, actigraphy data, and computer technology to differentiate between the control and conditioned participants. Based on wrist-worn ActiWatch data, this feature engineering process identifies depression and schizophrenia symptom clusters through several steps. Starts with preprocessing presenting 3 data representation forms. And for each form of time series 27 features were extracted to identify psychomotor and disorganization symptom clusters. The most expressive features were selected according to 4 techniques based on the wrapper and filter methods. Then examined using 5 classification techniques. Accordingly, 60 experimental models were executed for each dataset. In addition, 15 multi-label binary experiments were performed to challenge the system's proficiency in studying each group versus the other 2 groups. A daily time series study recorded remarkable results on bi-label classification problems classifying schizophrenia versus healthy controls and depression versus healthy controls. And also for multi-label classification, classifying each group versus the other 2 groups. This study ensured the current opportunity to obtain in computer-based objective assessment of mental disorder.